Okay, this video is going to be jam-packed with lots of stuff. Here's what you're going to find in it. You're going to find X and Y intercepts. We're going to talk about domain. We're going to talk about vertical asymptotes and horizontal asymptotes. So all of this stuff is going to be in this video. So stay tuned, and if you need to, you can skip through to find just what you're looking for. So first of all, looking at X and Y intercepts. So on a graph, if we think about the X-intercept, like if I draw a little mini graph here, X-intercepts are all these points where it's touching the X-axis. So that Y value is always 0 there. So if we want to solve for the X-intercept using algebra instead of using Desmos, plug in 0 for the Y value. So I see here's my Y value, so I'm going to plug in 0 equals X plus 2 over X minus 1. Well, I need to solve for X, so I'm going to multiply by what's in my denominator. So X minus 1 times X minus 1. These would cancel, and then X minus 1 times 0, well, anything times 0 is just 0. So we end up with 0 equals X plus 2. And then I just need to subtract 2, and I find that negative 2 equals X. This is where the X-intercept is. So if I write it as a point, it would look like negative 2, 0. On the other hand, if we think about a Y-intercept, so drawing myself a little graph again, our Y-intercepts are any places where it's touching the Y-axis, and the X value is 0. So if we want to solve this algebraically, instead of using Desmos, we plug in 0 for the X value. So all these places where I see an X, I'm going to put 0. So I can write this as Y equals 0 plus 3 over 0 squared minus 5 times 0 plus 2. Well, 0 plus 3 just gives me 3. 0 squared goes to 0. Negative 5 times 0 is 0, so I'm just left with 2. So my Y equals 3 halves, or I can write it as the point 0, 3 halves. So again, you can always find these intercepts by checking your work on Desmos and graphing the function. But when you're dealing with decimals, sometimes it's easier to solve it algebraically, so you find that exact value. All right, next up, we're going to talk about finding the domain of a rational function and how that kind of relates to vertical asymptotes. So domain, if you remember, the domain is the X values of our function. So for rational functions, there are going to be some places where the X value does not exist. It is not included in the domain of the function. Those places are anything, let me get a highlighter here, any values that cause the denominator to equal 0. So we don't want the X values that cause these denominators to equal 0. Equals 0, equals 0, equals 0. We don't want that to happen because those are going to be places where the X does not exist. It's not included in our domain. So what we can do is take each of these denominators I've highlighted and set them equal to 0, but say we want it to not equal 0 at that value. So X minus 3 does not equal 0. Well, add 3 to each side, and we find that we don't want X to equal 3, meaning X equals 3 is not included in the domain. For this middle function, I see X squared, so that's going to be my little reminder that I need to factor this. So looking for a magic number that multiplies to negative 3 and adds to negative 2. So I think I'm going to have negative 3 and positive 1. And then now that I have both of those, I can just split them up. So X minus 3 does not equal 0, and X plus 1 does not equal 0. Solving that, we find that X does not equal 3, X does not equal negative 1. Those are the values that are not included in the domain. And then last but not least, we have 2x minus 5 does not equal 0. So adding 5 to each side, we get 2x does not equal 5. And dividing by 2, we find that x does not equal 5 halves. So these are showing us the places where our domain does not exist. So if we wanted to write the domain as an interval, we can write from negative infinity all the way up to this point of 3, but then it doesn't include there. So we have to stop our parentheses and start a new set. So you can write your domain as interval for each of these, and you just would not include those values that we found. This is very similar to how we find vertical asymptotes, because vertical asymptotes are values for x that cause the denominator to equal 0. So everything we just found could be a vertical asymptote, but we need to make sure that those values do not cause the numerator to equal 0. So if it also makes the top 0, then it is not a vertical asymptote. So we could go back and check our answers. If we take 3 and plug it in, 3 times 2 would be 6 plus 1. So that's okay. That's not going to make 0 in the top. So this is also a vertical asymptote. If we check our middle one and plug in 3, or if we plug in -1, both of those are okay. They're both also vertical asymptotes. If we check the last one, 5 halves squared, if we plug that in, that's also going to be okay. So we happen to find all those vertical asymptotes as well. So when writing the vertical asymptote, we write it as an equation. So you would put the answer as x equals 5 halves for the vertical asymptote, but we say x does not equal 5 halves when writing the domain. So just be careful for what the question is asking for. In terms of these examples at the bottom, let's find, we'll do like 1 or 2 of them to find what are the vertical asymptotes. So we need to do some factoring because I see a lot of x squareds. So we're going to set the bottom equal to 0. So it's my magic numbers that multiply to +6 and add to -5. I think those are going to be -3 and -2. And so if we split this up, we get x minus 3 equals 0 and x minus 2 equals 0. So x equals 3 and x equals 2 are the vertical asymptotes. We just need to check if we plug those back into this numerator up here, x plus 1. Well, let's check. 3 plus 1 equals 4. That's good. It's not 0. And if we plug in 2 plus 1 makes 3, also not 0. So we're good. So both of these are vertical asymptotes. They've checked out. All right, I'll let you try those other examples on your own. I'm going to move on to horizontal asymptotes so we can wrap up this video. So our horizontal asymptotes, remember, look a little bit different. If I have a graph here, maybe something like this, and something like this. Our horizontal asymptote is that line going across from left to right. So our horizontal asymptotes we find a little bit differently. We're going to need to remember this table to help us. To find the horizontal asymptotes, we compare the degree, which is the highest exponent, of the numerator with the degree of the denominator. So there's 3 scenarios that could happen. Option 1 is that they are equal. Option 2 is that the numerator degree is less than the denominator degree. And option 3 is that the numerator degree is greater than the denominator degree. So let's look at some quick examples. Looking at the first one, when the degrees are equal, the asymptote is going to be found by comparing the coefficients. Or excuse me, not comparing, but dividing the coefficients. The coefficient of the numerator degree divided by the coefficient of the denominator degree. So if we look at this example, we see x squared is our highest degree in the numerator, and x squared is the highest in the denominator. So look at these two terms and take the coefficients, 4 and 2. So our horizontal asymptote would be 4 divided by 2, which just equals 2. To find the horizontal asymptote when the numerator degree is less than the denominator degree, that asymptote is actually always going to be at y equals 0. So if we look at this example here, we see an x down here, meaning its degree is 1, but there's no variables in the top, so that denominator degree is higher than the numerator degree. And then lastly, when our numerator degree is greater than our denominator degree, there's going to be no horizontal asymptote for these examples. So if we look here, we have x squared, and then in the denominator we have x. Well, the exponent of x is 1, and 2 is greater than 1. So that numerator degree is bigger, meaning there's no horizontal asymptote. So if we look at these quick examples down here, just pick out those terms that have the highest exponents. So in this first one, we have x to the first power and x to the first power. So those are equal. 1 equals 1, meaning that we've got scenario number 1 up here. This is scenario number 1. So our coefficients tell us what our asymptote is. So these coefficients also happen to be 1. So our asymptote is 1 divided by 1, which equals 1. All right, looking at our middle example, I have 2x cubed and I have x squared. So these look like the terms I'm going to look at, and I have 3 and 2 as my exponents. So 3 is bigger than 2, and I see that's going to be scenario 3 from my chart. The numerator degree is bigger than the denominator degree. So in that case, there is no horizontal asymptote. And then last but not least, in our last example, we've got no x term in the top, but we've got x squared in the bottom. This is bigger. It's like having a 0 degree up here. 0 is less than 2. So we're going to be dealing with scenario number 2 here, meaning that our asymptote is at y equals 0. Great job, everyone.